So anyway, that's a high-level overview of I guess, how Lucene works. And I don't really expect you to necessarily absorb all that right there. So what we're going to do is I'm going to go over a really short, like 30-line demo script that kind of walks through using the Java library for it. How exactly you would go about working this sort of thing. And then we're going to look at how it happens in open legislation. And hopefully I can convince you that it makes it really, really easy to produce the things that our website does. And then I'll answer any questions. You can ask questions about open legislation, Lucene, or PI. I don't care. You can ask questions about whatever. And maybe somebody in the room will profit from some of this information. So here's our demo. Okay, so here's our demo script, and so Lucene, like most databases, has a place on the file system where it stores all of the data that you're putting into it. So in this case, we're saying that we're going to put it in the home/demo/Lucene folder. I'm going to use file utils, which is part of the Apache Commons project. Apache Commons is awesome if you use Java. Just as a side note, we're going to make sure the directory exists, and we're going to make sure it's clean, so I can just run this over and over. And so then we're going to get started with Lucene. So the first thing we're doing is we're going to say we're going to use the standard analyzer. And the standard analyzer, like I said, removes stop words, splits things by spaces. I think it probably takes into account various different English idioms and things like that. It's fairly complex, but you aren't exposed to that complexity. It just kind of works, which is cool. And then I'm configuring it, saying that I want to use that analyzer and that I'm using Lucene version 3.3. And then I'm just telling it where the directory that I want to store the database is, and then I'm creating a new writer to that. And then from there, it's just as easy as adding documents to it. So in this example, I've got this demo document. And we can look at this function here. So you just create a document, you add a set of fields to it. The fields have names, they have values, and then you have two options, well, two important options. There's a lot of other options that you can probably use, but these are your two primary ones. You can store the field or not store the field, and you can analyze the field and you can not analyze the field. So fields that are stored are retrievable. So like when it finds the document and returns the results to me, it's only going to have the stored fields. And the non-stored fields aren't going to be there. So let's say, for instance, I decided that it was not important for the public to see the full text of the bill. It was only important for them to be able to find the bill by the full text. So I would set the bill text as not stored, and I would set it as indexed. So the full text would go through the analyzer, and it would create all the terms that point back to the document, but the document wouldn't actually have that information. And so those are the two choices you have with every field on the document, and they affect some of the different performance and use characteristics of the documents that you make. So I'm saying that the ID is stored, but it is not analyzed. So whatever I put as the ID, if someone wants to search by ID, they need to put in exactly that ID. And then if they don't, then it's not going to find it. And so keywords, I'm saying I don't want to store the keywords, but I do want to analyze them because I want to create terms for them. For the text, I'm saying yes, I want to store the text and I want to analyze it. Attachments, I do want to store the attachment, but I do not want to analyze it because it's probably just garbage anyway. And then there's always this concept of, and we see it here in this example query. We didn't specify a field to look for health in. And so Lucene, when you make queries, you always give it a default sort of bucket field that someone doesn't say what they're looking for, you just search in there. And so in this example, I'm saying that we want to have a default search field with ID, text, and keywords. So if they don't specify anything, we've got a field that catches those three contents. And then we just add the document. And when we're done adding documents, we can commit the changes. It has a very, very simple idea of a transaction. You can commit. It's basically document granularity. So you add the document, and then you can commit the document. And if for some reason I decided that I didn't want to add this document later on before I committed, then I could just unroll that. And then we optimize, which so when it builds these inverse indexes, it frequently will build them in a sort of fragmented way that is optimized for building the indexes, but not for searching the indexes. And so the optimize step basically merges those different indexes together to make it easier at runtime to find what you're looking for. And then you close the writer and you're done. And that's like an example of how you would load Lucene with a bunch of things. And then also all you need to do is just reduce whatever you're looking for to text, stick it in, and now you've got full text searching with Boolean logic capability across the facets, across whatever you put in. And so that's cool. And so then for the searcher, we create a searcher, which is pretty straightforward. You just tell it where the database is, and then it opens the connection to that. It is thread safe, and you can have active searchers and writers at the same time. So like with open legislation, we always have a single active searcher that gets used across all the requests. And then in the background, every time we get an update, we open a writer, we make the changes, we commit them, we close the writer. And that all happens behind the scenes without affecting the searcher. So the searcher gets kind of a snapshot in time of what the index was when it got opened. And then you need to, then you just close the searcher, and then you open it again, and now it's got the updates. So that's an interesting characteristic of how they went about doing that. And then, so you create a query parser, and the same thing it does on the way in with the documents, analyzing the field value and splitting it up and whatever, it does that to your queries as well. So if I was to search for bill text and then put like a whole sentence afterwards, it would send that sentence, put that query value through the analyzer as well and split it up into tokens, since that's how it does the matching. You generally would want to use the same analyzer both ways, but it's possible to achieve some kind of interesting effects by using different ones on different sites. And then you specify a default search bucket, and that's pretty much it. So you parse the query, you apply it to the search, and then you get the documents back. And they will, by default, be in some sort of relevance order. And it provides a lot of tools for affecting those orders without having to write your own algorithm. So you can boost certain fields to make matches in them more important for certain documents and not others, and things like that to manipulate your results. But really, I mean, this is what we're doing right here. We just we have a set of document schemas, and we reduce them. We reduce each field to text. We add it to a document, and then our out front, our web application here, we literally just take whatever you're doing. So like if you click this bills here, we just say, okay, you wanted all the objects, all the documents in the system of type bill, and then Lucene does all the work. And so, okay, well first, so are there questions right now as to what's going on? Yeah?
So you're stalling the situation so far as Lucene is the tool you're using, but
Right, so in our case, what open legislation is literally doing is translating the URL that you enter into a Lucene query, retrieving the results, and formatting them into a template. So,
so if somebody goes to open.nysenate.gov legislation, is that the page they see? That other page is what they see?
yeah, so this is running my localhost, but this is what they would see.
And so they don't, I mean, so the typical dumb user, as it were, they type in their query terms and...
Yeah, so our typical users for this aren't the public. It's usually people that work in and around the Senate and know the terminology that you would use to locate the bill.
I happen to support the New York State public interest group.
Okay.
And they are not sophisticated computer users because they do a lot of stuff with state legislation. So I actually have a specific curiosity about this.
So we do have an advanced search interface that hasn't been updated in a while, but does cover some of the common use cases that a user might have without having to write that query. You can kind of see that here. So if you're looking for bills with a certain sponsor, you know, or co-sponsors including, or all these things, we'll take the input from this form and we'll do the query for you. It's unfortunately not a part of the interface that's stressed at this point in time because we've had a lot of internal issues to work out, but over time we're hoping to make it much more friendly to the public that isn't as familiar with the...
So if I were to tell people, well, is that, you're explaining to us how Lucerne is making this work, but I don't have to tell them about Lucerne, I just need to give them the URL.
Yeah. So as far as the user's concerned, you know, there's a search bar and they can just type stuff in it. So like I live in Troy, so let's see legislation that affects Troy. You know, provides an optional pilot program to establish whatever. You know, or my senator is McDonald's, so I want to see what stuff related to Troy that is sponsored by my senator McDonald's. All right, so here's 3 that were introduced by Senator McDonald that had to do with Troy. And again, you could do the same thing in the advanced thing by saying full text search Troy, and sponsor is McDonald's. So there are a lot of issues with this from a user standpoint and a legislative standpoint that maybe we can talk with if